I welcome to all of you from the RBS Research Basic Research Academy. In this video, I am going to discuss about how you can check the normality of your data in your SPSS. This video is containing on the two parts, theory and the practical. In the first one, theoretical concept, I will provide you about how you can check the normality of your data, what normality actually is, and tools to check out the normality. If the data is non-normal, then how you can convert the non-normal data into the normal data. And then some practical work I will do at the end of this video. My name is Dr. Sumro and I'm from Shavdati University, Pakistan. As you know that I'm running one series of the data screening. So far, the two videos are already available on how you can identify the missing data and how you can identify the outliers. In this video, you are learning how you can check the normality of your data. In the remaining three videos, you will learn the linearity, homoscedasticity, and the multicollinearity. So these three are the topic which on the videos will be available very soon. Now, dear viewers, there are the three graphs are before your eyes. The first graph is there. Now, in this graph, this line is there. Now, these are smart circles. Now, these smart circles, these are our data points. If these smart circles are located exactly on this line, it means it is a normal data, like in this one. So, almost all the circles like these data points, they are located on this line. This is this can be called as we call this one as a normal data. And then you are observing some deviations is there. So now some deviation is there, but even though we can call it a normal data, because most of data points they are located on the line, or they are very near to the line. So now we can also call this one is a normal data, but here this data is sure it is a normal data. In this case, you see that almost all the data points, they are much away from your line. It means this is completely non-normal data. Then, now normality is a prerequisite are very important assumptions of the several tests which you are using in which you can apply on your data. Now, if the data is normal, then you can go for the parametric test, because parametric they are following some assumptions, some parameters. And then if the data is non-normal, then you can go for the non-parametric, because that is a distribution free, and this type of the test, they do not follow any type of the parameters. Now, this table provides you some of the examples of the parametric test. Any test you can choose from this table. And these are the tests which are non-prime. Anyone you can choose from these one if your data is non-normal. And then you can check out the normality of your data through graph, numerically through the table, and then through the significant test. Alternatively, you can go for the kurtosis and skewness. So now these are different tools are there through which you can check the normality of your data. Now, these are three graphs are there. Now, the first, now see here, this graph. Now here you are find the completely a very fine bell-shaped curve. If this curve is like shows the data is perfectly normal, that rarely it happens. Practically, rarely it happens that your data looks that the shape of your data looks like this. Rarely it happens. So now, so here the mean, mode, and median, they are located at the same position. Now, in this one is the negative skewness, where the long tail you are finding at the left side of your like this graph, and where the location of the mean, mode, and median is at the different places. And then this is the same one, but here you see the long tail is available on the right side of your this graph. That's why this is also a non-normal data, because most of data are lying on this line, that means beyond this mean, beyond this mode. And here the most of data is like beyond this after this before this median. So now if this is the situation of your data, this is the situation of your data, in both cases your data is non-normal. Now now if the what's happened according to the central limit theorem, if your data is more than 30, the normal is like the normal. Now, you can go through you can check out the PPT, PP plot, or QQ plot, or histogram. Now, these two grams can also tell you the shape of your data. And then you can also check the skewness. If the value of skewness or kurtosis is 0, it is perfectly normal. But in practice, it happens rarely, very rarely. Normally, some of the skewness or kurtosis values you are fine, but these should not be high. That's why some range is given, like this is the range where you can see these are the values of the skewness and kurtosis. If the values of the skewness and kurtosis are higher than these two values, then the data is non-normal. Alternatively, you can go for another very important test, that is one of the Kolmogorov test. And normally people call it the KS test. And then now normally happen that means if the value of the p value is less than 0.05, we say the test is significant. If the value of the 0.05 is higher than the 0.05, that means the test is non-significant. This is normally this happens. But in this test, the situation is very reversed. Now, what's happened that if your value is less than 0.05, it means it's a significant. If the result is significant, that in this one, it means the data is non-normal. If the result is non-significant, that means if the value of the probability value is more than 0.05, it means the data is normal. So this thing we should keep in our mind. One thing which I want to tell you about this one, that in the large sample, mostly the data remain normal. But how large, this is debatable. Because it is a subjective term. The different people have a different research, have a different opinion about the large sample. Now, what I believe always, that I believe if the data is more than the 200, it means the data is this sample size is a large sample. And in this one, most of the time, the data remain normal. But even though, I strongly suggest you please apply for at least for once the histogram, PP or QQ plot on your data, or the skewness cutoffs or case test on your data, even to ensure the data is normal or not. Then, what if the data is non-normal? The three methods are there, three alternatives are there. Transform the dependent variable. Only dependent variable you can transform, not the independent variable. Now, how to transform? Three tools are there. In the next slide, I will discuss. And then use non-parametric test, as I showed you the two tables. And the one was a parametric and another was a non-parametric. Any one you can use. Now, any test from the non-parametric you can apply if your data is non-normal. The third thing is that even though it is necessary to apply the parametric test, even though your data are non-normal, then please provide some justifications over there that why you are applying this technique. And then now these are the methods through which you can convert your data, non-normal data into the normal. Log transmission, you take the normal log of your dependent variable, and then you can make your dependent variable from non-normal to normal. You can also take a square root, and you can also do the reciprocal transformation, where you can divide all the values by the 1. You can divide them, and this way you can convert your non-normal data into normal. So these are three methods are there. Again, just to revise you that these are two graphs are there, the BP plot of the hygiene data 2, because the data which I'm referring here, now this data, there are the 3 days data, is it data day 2 and day 1 and day 3. Now in the day 2, now see the data is non-normal, because this curve, this line is there. Most of the data points are circled, they are away from this line. That's why we say this data is non-normal. And here, and almost all data points are located on this line. That's why we say this is a normal data. Now, very important thing, that's about the KS test. If you apply this KS test on your data, how to report these results? It's very simple. There's the only problem. First of all, this test is being denoted or known by the D. And these are freedom are also there. Now, this is a way through which you can report your this result. For example, data hygiene score on the day 1, you can D is for the gas test. These are the 810. These are the your sample size, and then we are more important interested in this one. If now the value of p value is 0.097. Now 0.09 is higher than the 0.05. It means our test is non-significant. When our test is non-significant, it means the data are normal. However, in the day 2 and the day 3, our data are non-normal because the value of day 1.001 and the 0.00. That means actually there is the p value of the both day 2 and both day 3 are same. So even though, but now these two values are 0.001 here. Now these are less than 0.05. That means that now the test is significant, but the data are non-normal. And here the tests are insignificant, the data are normal. Then how you can check through the normality curve and through the skewness and kurtosis. So in this section, I'm going to check out the normality of our data. This is a practical part of this video. Earlier, some of the theoretical I discussed very important aspect of the normality. In this one, we are going to understand how to check the normality. As I discussed in the theoretical part, there are two methods to check the normality. The first method is through the numerically you can test, and we can also test graphically, and then we will apply one test. Let's to start to check the normality of the data numerically and graphically. How to do this one? It's very easy. Just go into the analyze, then descriptive, and then go into the frequencies. Now after going to the frequencies, then what you should do, that you should move the variable of your choice. In this data, there are the three variables are there: day 1, day 2, and day 3. So now we want to check the normality of the data through two methods, through the tabular form and the graphically. So now first we are going to move the day 1 data from here to here. Now, so here the some menus are given, especially this one menu is there. So you are required uncheck it, because if you check it, it will provide so many unnecessary details. Already you know about all these details. In order to save your time, please uncheck it, and then go into the statistics. The same that means the menus which are the result which you are going to produce through this technique, through this check, the same results are also available here. What you do, then you should check the in the required menu. For example, I want mean, median, mode, as well as I want to also check the skewness of this data. And if you are interested in the standard deviation, okay, you can. And then some are the ranges are sometimes it's important. Okay, then continue, and very important, and just go to the chart and please mark this one chart along with the normal curve, and then press continue and then press button OK. Now once you press the button OK, now this type of the results will appear to you. Now in the first one is the hygiene day 1 data festival data. Now this is the statistics of your first variable. Mean is 1.7, median is 1.79, and mode is 2. Okay, now here standard deviation. If we see in standard deviation, it's 0.9444. And then the skewness, in which basically we are interested, the skewness is 8.865. So now here I would like to share some of the rule of thumb to check the skewness or the value of the skewness. So in this regard, the values are also appearing on your screen. If the skewness is between -0.5 and 0.5, the data are fairly symmetrical. Symmetrical means the data is fairly normal. And another rule is if the skewness is between -1 and -0.5 are between the 0.5 and the 1, data are symmetrical. Again, that's a good value. And then if skewness is less than -1 or greater than 1, the data are highly skewed. Now, these are the three rule of thumbs are there which are appearing on your screen. In this one, see the level of the skewness. Oh, that's quite high than our, because the last rule of thumb is if it is higher than 1, then the data is skewed. So now this tabular, this result show in the table that our data is skewed. Now, if you come if you see the graphically, the histogram shows also a long tail here. This long tail is here. This all shows the data is non-normal. Now, then another form is that we can do. We can go into the test. If you want to run the test, then you can also go into the analyze, and then just go into the descriptive statistics and go into the explore. Once if you enter into explore, then reset all the settings, and then as we are working on the day one, then move this variable from this list to dependent list, and then go into the statistics. We do not require anything, but just let it from here, and then we are interested in the plot. Stem memory, uncheck it. If you are interested, you can put the histogram, and you can also check normality plot with test. So now this menu will produce the plot along with the test. Now test, about the KS test, and then continue, and then press OK. Okay, now the results are before you. In this one, the first one is our case processing summary. In this one, this is the name of the variable and the number of the observations, and case missing, 0 missing, total case are there. Descriptive statistic, if you go inside this one, and we are interested only into the skewness, and it is 8.8, quite high than our range. If it is higher than 1, that means it is surely there is a skewness and the data is not symmetrical or is not normal data. Now, the two tests are here. The first test is a KS test or Kolmogorov Smirnov test, and another is the Shapiro and Big test. So now actually both tests are doing the same job, but this test is less popular than this one. So that's why we are focusing more this one, and then our estimate is a 0.83 degrees of freedom are 810, and significant is a 0.0. Now, as in the theoretical section of this one, I told you that if the significance level of this one is less than 0.05, it means the data is non-normal. The same thing that here, skewness is 8.8. Now, thus this the result of this test is going to testify that this skewness. Then now the tabular form test and graphical, you see that the data is non-normal. Again, see here. Now, this is the histogram, but it has no curve, so that's why sometimes it's difficult to know. Now the data points are much one. Now see the data are lies from 0 to 20. Probably there's a problem with our data. Now, what are the problem is there? Then come, our QQ plot is also non-normal, because I showed you this the two QQ plots in the theoretical section that if the values, now these are the small circles, if these are away from this main line, it means data is non-normal. The same graph is showing that our data is non-normal. And then, okay, this is our another graph which shows that there is some problem. The problem lies here, static. Probably this static shows that there is an outlier in our data. So that's why now see all the results are the data is non-normal because of this outlier. Then now our outlier is available in the observation 611. Now we have to solve this problem. How to solve this problem? It's very easy. Solve problem is very easy. Now, as you know, our observation was 1111. Now, case, how to find out this? Go to the case, and then we have to find out the 611, and then go. Okay, and now we reach on 611. Oh, there's a problem. There's a 20. Right now, in the most of other cases, it is a 212121 RR. The higher value is 3, but here the 20 is there. So now this is the outlier. Now rest of the values are within the range after 1 to 3, but this is a 20, this is out of the range, and now it's an outlier. Now we have to remove this outlier and just remove the 0 and make it 2. Now once you have removed the outlier, then again we are going back to apply the same explore technique, and then we require, okay, all the things are checked, that's fine, just press OK. If you press the OK, and then you will get OK. When you press the OK, now you get another result. This result is same. Now once you press this button, you get this another result. The first one is a data day 1. The same thing is the data processing summary. Now here in the descriptives of the day 1, now see here skewness is now has been reduced. Now it has been in minus 0.004. That means it have now become our range. So please remember rule of thumb number 2. So now if it is between the -1 and the -0.5, then the data is normal. Now this level, now after removing the outlier, the value of skewness has been reduced. Now from here, like the descriptive, now here the skewness is a 8.8, but here after removing this one, the same has become now the same has become -4. Then after removing the outlier, the value of this one has been low down. Now the 2 tests are there, but we are interested in this test, KS test. In this one, now see our value of significance is above 0.5. If the value of this significance is above 0.5, it means our data is normal. Now from the test shows that the data are normal, and this tabular form skewness also shows the data are normal. Okay, now histogram. Okay, predefined histogram is available where the data looks normal. And then this is a QQ plot. Oh, wonderful. That means almost most of the vast majority of the sub data points now are falling exactly on the line. This shows that our data is normal. And then if you go on this one now, this the height of this one has been increased. Now see the height of the box plot was very narrow, but after because of this outlier, when you remove this outlier, now see the height, and now it is in the actual position. So now this is one method through which you can check the normality of your data. And then if you are interested in more, you can also do some other things with the rest of the values. Okay, and what we can, okay, first we go to the frequencies. That's good. Reset the things and then go to day 2, and then do not do it. Okay, I think we should check something. Okay, mean, mode, median, and then range. I think should we provide, because last time we did not provide the range. That's why we could not the range, because of the tabular form we did not find any outlier. But if we provide the range will tell us that the minimum and maximum. Okay, and then standard deviation, if you are interested, okay, is skewness. That's very important. Continue, and chart is obviously very important. Chart histogram along with the normal curve. Okay, and then okay, now the results are before you. In that one, our range is 3.44. Okay, and then what important, 1.9. So now this 1.9 is looks that the data is now normal, because it is higher than the 1. The rule of thumb 3 is the value of skewness is higher than 1. The data are now normal. The same thing is there. Now this shows a long tail. There's a big long tail which shows the data are non-normal. And then now through the tabular and through graphically, that means that we prove the data are non-normal. Then we are going now towards the data. The simple, go into the explore, get that back, and then forward this hidden 2 and just press OK, and the rest of the menu should remain same. Now here. Skewness is 1 more, that means more than 1. The data is skewed definitely. Now the test of normally that shows the values. Now the values probability is less than 0.05. The test shows the data are non-normal. This table shows non-normal. Histogram also shows big tail on the right side. So that means this graph histogram also shows the data is non-normal, and then again QQ plot again shows that the most of the almost more than half of the data points are away from the data line. That's why our this data is non-normal. And then again see so many issues are there with this data. So that's why we are sure that our data are non-normal. So okay, now dear friends, we let me say prove that the day one the data earlier it was non-normal because the presence of the outlier. When we remove the outlier, then now the same data is normal. And then day two, the data was non-normal. Now I'm leaving this option on you to check out, to work with that one and to check out either the data is normal or non-normal. Okay, so this data is also available at the is a link at the end of this video. You can find out this one, or below of this video you can find out this one. Thank you for watching this one, and I hope you like this video.